Our final type of special factoring pattern is a difference and sum of cubes. So unlike the difference of squares, which only works when you are subtracting two squares, we have patterns that we can use for differences and sums when we are adding or subtracting two cubes. Two formula patterns to be aware of. So when we are adding two cubes, the special pattern looks like this. We have a binomial times a trinomial. And when we are subtracting two cubes, we have a very similar looking setup, but with two noticeable differences. When you're trying to remember the formula for factoring a cube, whether it be a difference or a sum, the easiest way to remember it is that all of the terms all fall in the same order. It goes AB, A squared, AB, and B squared. The key is to remember the order of the signs. And usually the easiest way to remember it is that this sign in the original binomial matches the sign that's in the first parentheses, and that is the opposite of the sign in the second parentheses. And the same thing happens down here. This subtraction matches that minus sign, and then that minus sign is the opposite of that middle sign. So if you're trying to quote unquote memorize these factoring patterns, that's an easy way to remember the signs. And of course, all of the individual terms go in the same direction. So let's try a few. Our first one, we're going to start with a fairly basic one, x cubed plus 125. X cubed is, of course, x times x times x. 125 is, of course, 5 times 5 times 5. Using our special factoring pattern, we're going to say x plus 5 is going to be in the first parentheses. We want to match the sign of the original binomial. And then inside the second parentheses, we're going to square the first term. We're going to multiply the two terms together. We're going to square the last term. This is always going to be a positive, and our minus is going to come right there. Trying another example, we have 8 minus 125 x cubed y cubed. 8, of course, is 2 times 2 times 2. 125 x cubed y cubed is, of course, 5xy. That's that same cube that we had up here, so we'll use the 5 again, but this time with the x and the y. Our first parentheses, we will match the sign. Our second parentheses, we'll square the first term. We'll square the last term. The middle term is the two of them multiplied together, so that's 10xy. And we're going to have plus signs in both of the spaces here. If at any point you want to convince yourself that this process is working, you can always multiply out and make sure you get back to where you started. It probably wouldn't be a bad exercise to do that with one of these two original rules so you can see what that looks like. So let's take a plus b times a squared minus ab plus b squared. And we're going to ensure that this is a cubed plus b cubed. So each one of these multiplications, a cubed minus a squared b plus ab squared. And then we'll do the second round of multiplications, plus a squared b minus ab squared plus b cubed. You'll see the two terms in the middle, this one and this one are opposites, and this one and this one are opposites, and we're left with our target of a cubed plus b cubed. And you could do the same thing with a cubed minus b cubed, and you could do the same thing with either of these examples. But the difference of cubes is usually one of the easier ones to spot. It's very much like the difference of squares. It's two terms being added or subtracted, and then if you can identify those cubes. But as we have advised for all of these different special factoring patterns, do not forget to look for a greatest common factor. It would be really easy to look at something right out of the gate and say, that's not a perfect square, and make the observation that something was not a perfect square or a perfect cube, but then only to have that GCF be there, and that's what's keeping it from being there, from being a perfect square or a perfect cube. So something to keep an eye out for, again, here, the greatest common factor.